All right, good day and welcome back to Everything Mathematics. And today we are going to continue our series on logarithms. We would have started by establishing the concept last week, Friday. And this week we're going to delve into some rules and some general questions that could come under logarithm. As usual, I like to look at the various concepts and rules first and questions, adequate question that goes with that specific rule. And hopefully at the ending of it all, we're going to look at several general questions that could possibly come under the rule of logarithm. Today, however, we're not going to deep into the rule itself. Last week, we basically looked at the fact that a log is generally written as, this one looks very thin. Yes, we look at a log and we basically established last week that generally we write logs like this. So we have log A of B, and that could be equal to C. C, not zero. Zero is a specific rule, equal to C. And what we basically said is that the A is the base, the B is whatever result we get from raising the base to C. So usually we have an effect like this. A raised to C is equal to B. So in essence, log AB equal to C can be written as, or it's equivalent to A raised to the C, which is equal to B. And this is what we established last week to be the index form. So what I did last week, we looked at some various index forms and we converted it into log forms. To start off this week, we're going to basically do the opposite. So I will just give you some basic log forms, and all you need to do is be able to convert it into index form. So that should bring us to the end of today's video. So all we need to do today is write in log form. No, I lied. Today we have to, we have to write in log form. No, today we have to write in index form because last week we wrote in log form. So write in index form. Write in index form. And the index form, remember, you have a base and you have something raised to that power. So quickly, let's just do a busy few. So if we have log 3 of A is equal to 10, then number 2, we have log 5 of 15 is equal to 3, if that's even possible. Then we have number 3. This is not actually possible. Let me put this. Where's the eraser? So let's say log 5 of 25 is 2. And let's do some algebra for the rest. Log x of y is equal to, let's say, p. And 4, let's say, let's use a number for this one. Log 2 of 8 is equal to 3. So one of the things we need to be efficient or rather proficient with is if we're given in the log form, we have to be able to revert it into the index form. So let's see if we could quickly do this. This is where, of course, you can pause and attempt. I, of course, will just progress. So for the very first one, we have log 3 of A or log base 3 of A is equal to 10. And remember the effect is something like this. 3 raised to this is equal to this. Good. So number 1, if I go to write that in index form, I'm basically saying 3 raised to the power of 10 should give me whatever A is. And this is something that we could work out. And notice right away, sometimes when you get a question, well, maybe I'll address that after. Good. If we look at number 2, we have 5 raised to the 2 is equal to 25. So that should have been 5 raised to the 2 is equal to 25. And this is actually a true statement. So we have 5 raised to the 2 have to give us back this number here. For number 3, we have algebra, but again, the concept is the same. The x here is the base. So the base has to be raised to the p to give us whatever y is. And this is just an algebraic representation, basically, of the rule. And last but not least, number 4, we have the base is 2. So 2, the index is 3, and that's equal to 8. And this is also a true statement. Good. I was about to say earlier, this is basically the foundation or the basis of logarithms. Of course, this could progress into getting into doing more complicated questions, and that's of course where the rules also step in. But with the foundation that we would have set so far, right now, you have to be adept enough to be able to solve a question like this, for instance, algebraically. So sometimes they give you as a log, and there is an unknown. Basically, there's only one unknown here. And when given as a log, sometimes it also serves as a disguise. Sometimes, like in this case, looking at log 3a, so log base 3 of a is equal to 10. This a here could have been a pretty disguise as to finding out which one is the unknown. But notice when we wrote it in the index form, it's only something we have to basically raise the power to get a. So if you were asked, for instance, to find a, this is where the knowledge of converting to a log form or to an index form could help you significantly. Sometimes you have to use logs to find unknowns, but sometimes it's just a simple matter of reverting to come back to what we initially want to find. So to wrap up this video, let me just generalize what we look at today and last week. So last week we look at if we have a raised to the b equal to c, we said we could easily write this in log form as log the base, which would be a, the result, which would be c, and the index, which would be b. And this is really the golden rule. We have to be able to go to and from. So we have to be able to jump from this rule here to this rule here. We have to be able to do that. And likewise, we have to be able to jump from this here to this over here. Index to log, log to index. And sometimes just doing that could help us to see unknowns or to solve unknown questions when dealing with logs. And this is really as basic as they come, as basic as it comes. So we're going to wrap it up there for today. And in tomorrow's video, we're going to go straight on to looking at rule 1. So again, as always, feel free to like, share, and subscribe if you haven't as yet. And until the next one, you take care.